All right, so I've got my 7.7 notes here. It says the central limit theorem is what we're talking about. So central limit theorem, it's for all samples of the same sample size, where the sample size needs to be greater than 30. The sampling distribution of the mean can be approximated as a normal distribution. So even if you don't know it's a normal distribution, if the sample size is greater than 30, you can assume it is a normal distribution. But if you do, your standard deviation has to be the original standard deviation divided by the square root of the sample size, okay? So you need to have certain given pieces of information. The given first one is that the population with any distribution has a mean of mu. So the mean doesn't change, and the standard deviation will only change if you consider some sort of number of sample size. And that simple random samples have been taken. So the simple random samples isn't as important, so I'm going to skip on. So here are my requirements, okay? If the sample has a normal distribution or a sample size greater than 30, so they can either tell you it's normally distributed or tell you that the sample size is greater than 30, then the means will be the same, but you have to change your standard deviation. So this is your new standard deviation. It's the original divided by the square root of n, which is the sample size. And that's how you find your new z-score, is use this standard deviation instead of that standard deviation. Okay, so if the original population is not normally distributed and n is less than or equal to 30, then the distribution of x bar cannot be approximated, and you need to find another way to solve this question, which you won't. You'll just say it's not solvable. Okay, so make sure you check the requirements. Make sure it says normally distributed or the sample size is greater than 30. Okay, are you trying to find an individual value, or are you trying to find an average of multiple samples? Okay, if it's an individual value, you can use the regular z-score formula. You can use the regular normal CDF and all that jazz. If you're trying to find for multiple samples, like if you've got 15 or 30 or 45 people that you're checking this off, then you have to use this new z-score. But you can still use normal CDF and all that jazz. So I have a couple of examples to help us out. The first one is to find the z-score itself. Okay, this is a plug and chug type of question, so this is one we're going to need a calculator for. Okay, so if I have all my information, I can figure this out. So I'm going to plug it in as is. So I want a fraction first and foremost. The numerator is the original value minus the mean, and then I'm going to divide this by the original standard deviation divided by the square root of the sample size. Okay, so this is my z-score. I think I wrote this one wrong, but this would be my z-score, and then I would run with this one. I think the x bar wasn't supposed to be 92.3, but you get the point of how to plug it in. Okay, so you plug it in, and that's how you get your new z-score. That's kind of the only difference, is that I can do this for multiple samples now. So I took a question from the homework, and I'm going to solve this with you. So it says the overhead reach distance of an adult female are normally distributed with a mean of 205.5 centimeters and a standard deviation of 7.8 centimeters. So I have three questions. I want to find the probability that an individual distance is greater than 215.5. I want to find the probability that the mean of 15 randomly selected distances is greater than 204 centimeters. And then I want to know why can I use the normal distribution for part B if its sample size is only 15. Well, I'm going to answer the third one first. I can use the normal distribution for part B because in my question it said the population is normally distributed. So because the population is more normally distributed, I can use this new thing, because population is normally distributed. I was able to use this even though the sample size was small. All right, So part A, I wanted to find the probability that an individual is greater than 215.5, okay? So 215.5, I need the z-score. This is an individual, so I can use the original formula. So 215.5 minus the mean, 205.5, all divided by the standard deviation. Remember, 2 decimal places, so 215.5 minus 205.5, I believe this is 10, divided by 7.8, and I get 1.28. 1.28 is the z-score. And I want greater than, that means this is the smallest number, so I'll do the normal CDF. Okay, I'm going to start at the 1.28, and I'm going to go greater than, so 1e to the 99. These are z-scores, so my mean is 0 and my standard deviation is 1. Okay, once I'm doing this with z-scores, I have to do it this way. Okay, so here's calculator again. So 1.28, 1 times e to the 99, 0, 1. All right, so I get 0.1003 to 4 decimal places. All right, and then the next one, it says find the probability that the mean for 15 randomly selected distances is greater than 204. So I need to use my new z-score formula because I have a sample size included in my question. So the top doesn't stop, it's still 204 minus the original mean, which is 205.5, over the original standard deviation divided by the square root of the sample size. All right, so calculator, 204 minus 205.5, and then 7.8 divided by the square root of 15. Goodness gracious, you can't even read that because of the glare. There we go, maybe. Herg. Still such bad glare. Whatever. Enter, and I get negative 0.74. Negative 0.74, because this is a standard deviation, or this is a z-score. I only need 2 decimal places. Now I'm going to go back to the normal CDF, because it did say it was normally distributed at the beginning, right? Normal distribution. So my z-score, it said greater than, so the smallest number is negative 0.74. I'm going to go to 1e to the 99, and still 0, 1 for the mean and standard deviation. Alrighty, so I'm actually just going to repeat this one and change the z-score to negative 0.74. All right, so I got 0.7704. 0.7704 is the percentage I got, or the probability I got, not percentage, just not a percentage. All right, so here's for 7.7. You're pretty much going to do it all this way. Sometimes it will not say normally distributed, and my sample size will not be large enough. So at that time, you have to say, I cannot calculate this. Cannot do it. All right, so keep that in mind. All right, see you later. Bye.